This is Unleashing the Power of Time Series Data with Amazon Timestream. We'll be diving into choosing the right time series database for your needs. So welcome, everybody. My name is Dan Marks, and I run the business functions for Mactores. So with that, I'd like to welcome Nanjan Amarji, our COO and principal architect at Mactores. And he will be having a discussion today with Victor Servin, our senior product manager for Amazon Timestream. Well, good morning, gentlemen, and thank you for being here.
Good morning. Glad to be here.
Good morning. Let's start with the basic. Can you explain to our listeners what the time series data actually is?
Yeah, of course. First of all, I want to start by saying that I'm pretty sure you have time series data in your company. Whatever is your use case, whatever is your industry, there is time series data there. And what's time series data? Time series data is not other than data that has certain characteristic, right? So it's usually always timestamped because you need the time dimension to be a time series data. This data can be generated either predetermined intervals of time, or could be event-based, which pretty much means that it can happen at any time. Is usually in high volumes, right? In the world we live today, everything is generating data. Everything is measuring something. So if you are measuring anything over time, you are using time series data, regardless if you have a purpose-built database or not. Another characteristic is time series data is usually immutable. What this means is data that usually don't change after the fact. And why this makes sense? If you are measuring the temperature of a certain machine, you are not going to go back in time and say, oh no, actually I want the temperature to be different. If you are measuring the quality of experience of an user on a streaming platform, right, you are not going back in time and say, oh no, the quality was better. Or if you are measuring your bank account or some particular stock in the stock market, right? All these share the same characteristics. A lot of data is generating. The most important thing to figure out what's going on is to be pretty much measured over time, right? And the data that was already generated and already measured, it will not change afterwards. So that's a good summary of what time series data is.
Something that brings me to the live analytics portion of this. What is live analytics? Has it got anything to do with being able to analyze time series data in real time?
So we have, within Timestream, we have two engines, right? We have Amazon Timestream for Live Analytics, and we have Amazon Timestream for Influx DB. Live Analytics is our serverless offering. It's a purpose-built, fully serverless database built from the ground up to be able to manage like massive scales of workloads. So why is called Live Analytics? Because it kind of have a good mix of both worlds, right? You can do real-time monitoring and analytics, but you can you can do real-time monitoring on live data, right? But you can also do like long-term analytics, because usually the types of customers that use this particular engine have not days or weeks, they have years worth of data. So yeah, they do some analysis on what's going on right now, but usually they use this for the longer tail, right? Root cause analysis or machine learning training with all data. They compare seasonality across years or even decades, right? So that's what live analytics is built for.
Okay, and how would you talk about like the key benefits of using Timestream as a database?
So the key benefits are very tied to, okay, the first idea is as a customer, you need to figure out, okay, do I need time series data, right? Because once you get to that realization, then you will start seeing the benefits. So for example, when do you need a time series data, right? So I would usually say, if you have one or two time series related workloads, which are these? You are doing time aggregation and trying to figure out certain trends, right? Or you have some alarms there that if a particular metric goes out of phase, you want to know. But if this is like 5–10% of your problem, let's say, of what your business consider critical, probably you could do with whatever you're using right now. Now, if you are generating a massive amount of time series data, and this is critical for your business, like I mentioned before, imagine you are running a very large streaming platform or an online game in which you want to understand at every second what the quality of experience of your users is. So what a time series engine will allow you to do is, first of all, ingest very large amount of data very fast, right? Both of our engines offer a write-to-read latency that is below 1 second, right? So you can be writing, depending on the engine, but let's say any of these can manage around Influx DB. Let's try to be more specific. With Influx DB, the managed version we have, you can ingest up to around 800, let's say 1,000 records per second. And you can have those records readily to be read within one second, right? In the case of live analytics, is a slightly different architecture, which means that you can go way over that. You can go millions and millions of records per second without any issue, and that will be available to be read and processed and analyzed and very fast. Another advantage of these engines is that you can do more than just show the data, right? Both of the engines have things like automatic data processing and aggregation. What does that mean? Imagine you are generating data every second or multiple times per second. That is very common if you are, we have customers in aerospace. We have customers in industries like energy and other kind of manufacturing use cases in which they can generate 3, 4, 5 data points in every second, but they want to look deviations in aggregates of, let's say, 1 or 2 minutes, right? Usually you have 2 ways of doing that. One, you run a query that will use an aggregation of 2 minutes, but you are processing a very large amount of data. Imagine if you are doing that every time you refresh a dashboard. The amount of processing power you will need will be massive. So what both of our engines offer is you can do automatic aggregation, for example. So you can create that every 2 minutes, for example, they will take all that sub-second data and aggregate it and do an average with a 2-minute grain that you need for your dashboards or your alarm and notifications, for example, right? So that is all built into the engine, and you can do time series specific analysis. You can do interpolation. So there's a lot of things that will help you to take the best out of your time series data by using a purpose-built database like the ones we offer.
Okay, so like you mentioned about Timestream for Influx DB, could you elaborate more on what Timestream for Influx DB is?
Of course. Also, Influx DB is the most popular time series database out there, right? The Influx DB open source has been very well received by the community in the last 8, 7 years. They have not only a very vibrant community, but they offer a whole family of tools that helps to basically ease up your journey into the time series world. Like they offer the Influx DB open source database. They offer what is called Telegraph, which is a client that will help you to ingest. I think they have more than 100 connectors now. So you can get data in 100 different formats from tools that goes from Prometheus to text files and everything in between, and then automatically process and send that into your Influx database. And that is all supported not only by Influx Data, that is a very good partner of us in this project, but also by a vibrant community, right? In terms of specific characteristics, because we get this question a lot, why do you have 2 engines? First of all, as you know, we at AWS are a strong believer in providing options to our customers and not only option, but also a purpose-built approach when it comes to the databases, right? We don't believe that the one size fits all, right? We have databases for graphs like Neptune. We have databases specifically built for columnar data stores. We have databases for time series, right? So why we offer 2 engines? Because as I mentioned, InfluxDB is a very well-known and very well-adopted tool. And a lot of customers just want to keep using the same tool, but they don't want to manage it, right? When you move to a managed service, we take care of all the things that are not as fun, let's say. So we take care of OS patching, engine patching, the scalability part, durability, backups, and you can focus on your problem and keep evolving like your products, right? So that is one big advantage when you move from a self-managed Influx DB to a cloud Influx, and we are adding some extras there that customers expect when using it through AWS. Data encrypted at rest and data in transit. We do offer a high availability option in which we will deploy a secondary instance with synchronous replication. This means that if your primary goes down, we automatically detect that and fail over to your secondary node, right? And these are things that are not available currently in the open source. And we have more surprises coming because, as I mentioned, this was built in partnership with Influx Data. And we are going to start a license add-on program in which we will add things that are not there in the main branch of the open source as a license add-on that will keep extending the capabilities of this database.
Okay, so let's say in a gaming type of a use case, like if there is a gambling engine part of the entire gaming setup, would like kind of gambling engine that kind of does the odds for the specific events to occur, can Timestream DB be used as a like good use case for that?
So we have seen our databases used in all kind of scenarios. So in gaming, for example, you can monitor your infrastructure. So you can make sure that if it's a tournament, for example, you can scale your infrastructure as fast as possible so everyone will have a good experience. And then you can, again, if there is too much like idle capacity, you can reduce that infrastructure again. We also have in the gaming, the same industry, use cases about quality of experience within the game or within the app, right? In these cases, they want to track what's the latency between a customer trying to either acquire a specific add-on for the game or just start playing the game, right? Figuring out, oh, this particular node is overload. So the users in these regions would either get a new node deployed or they need to be moved to another node because we want to keep the quality of experience at best. If it's like a gambling scenario that I think you mentioned, you could use a time series data also to keep track of, okay, what's the current stats, right? And this is also immutable, right? Because the potential gains of whatever you are making your bets will change very fast over time. So you need to keep updating that as fast as you can, but you also need to read that information to provide feedback to the customers that are trying to engage with the platform.
Okay, so we spoke about the real-time infrastructure monitoring, like some telemetry data, and then being able to share some customer dashboards, those being the popular use cases for Timestream. How does quality of video streaming become a use case for Timestream, and then what our media companies can leverage by using Timestream for that use case?
So when you think about video streaming platforms, and let's try to put kind of a hierarchy of what's important. Obviously, the content is the most important thing. If there is no content, you can have the best technology in the world. If users are not going to like it. The second thing is the quality of experience, right? This is entertainment for most of us, and we want to have a good time. So what I mean by quality of experience, you want the buffering time to be as low as possible, right? And you achieve this by if the network conditions, for example, on one particular device in one particular part of the world change for some reason, you want to really fast react and change the quality of the video you're streaming, changing the codec, changing the resolution, whatever it may be, right? You want to make sure that the app experience between when you are browsing the catalog, right? If it takes 10 seconds every time you move your remote control to see another section, probably users are just going to leave and jump to another service, right? So being able to detect this as fast as possible, allow these players to react and also be more proactive, right? When you have an infrastructure already deployed and you are using time series data, it's a very good tool to do forecasting. So you can know under which thresholds certain parts of your infrastructure could start affecting other places. So you can have your forecast, and when you start seeing that there might be a deviation, you can be proactive and fix that before the problems arrives. This is especially important in spiky traffic. When a streaming service has spiky traffic, imagine you are a service that provide access to live content. This could be a football match. This could be the Olympics, whatever it may be. You want to see that live. In live events, having the lowest possible latency is the most important, because 1 second might not seem a lot, but at the beginning of a 3-hour event, if you have a 1 second delay per minute, imagine what will happen at the end, right? You are 180 seconds behind. Your neighbor is already yelling stuff, and you are still kind of living in the past. So using time series data will allow you to not only learn from what can happen, but also react way faster, so bad things won't happen.
Absolutely. So if a customer wants to migrate their Influx DB from on-premises to AWS, what are their options?
So right now, if you are using self-managed Influx 2.x, is actually very easy. We have, and we can share that later, we have a blog post that talk about step-by-step how you can migrate the data, and we even provide the scripts for you to do it, and it's very easy to do. It will probably take you a few minutes to configure, and then you just have to run it. In the same blog post, we also explore, okay, what happened if you want to do more or less a real, a live migration, which means that minimum downtime, and then migrate the data as data is still coming into the system. We also have an example on how to do that. So if you happen to have any of these two cases, we got you covered. We also plan to expand that to explain, okay, because a lot of people here might be running Influx open source 1.x, right? So if they want to move to Timestream for Influx DB, which is currently running in 2.7, there is an intermediate step that is upgrade the database to 2.x and then do the migration. And we are also going to publish a step-by-step on how to get there.
Right. So if you look at it from what we discussed, like Timestream can do complex analytical queries, and then with the Influx, you can manage like automated alerts and notifications, and then so on. How does customer get to decide which is the right solution for you? Like, how do I choose Influx Timestream, like Influx and live analytics for my use case?
So actually, if we think about like core features, right? Core features, both are pretty much the same. Both have real-time processing capabilities. So in both, you can create, in InfluxDB is called tasks, in which you can create a task that will be executed every X amount of time. And the result of that will be stored in another InfluxDB data store that is called a bucket, right? In the case of Timestream for InfluxDB, you have schedule queries, which will do exactly the same. These schedule queries will run every X amount of time, and the result of that processing will be stored also in another table. So in terms of core features, both databases support mostly the same features, right? They both have integrations with Grafana, which is, I would say, the preferred tool for time series workloads. And in Grafana, you can do any kind of dashboards that you can imagine. You can create alarms, notification, everything, right? But the difference that we see right now is mainly on scale. So let's say 3 things, right? When you need to decide which one do you want, you have to look at 3 different potential variables. One is the query performance. As I mentioned before, InfluxDB is an instance-based system, which allows it to be extremely fast. So a well-modeled InfluxDB use case, you can get query latencies below 50 milliseconds, for example. Whereas Timestream for live analytics, this is a fully distributed engine, which means that you can start from 0 and go all the way to 3 gigabits per second of ingestion. But in a full distributed system, you know that things might not be as snappy, because it's not like the data is right there in the same instance that received the request. So in live analytics, our query response times are more in the neighborhood of 200 milliseconds. So first question is how fast you need the query response to be. The second question is related to scale, ingestion, and queries, right? Again, Influx DB is a great engine, but it's instance-based, at least the flavor we offer on AWS, which means that you will hit a limit eventually. For example, in our tests, as I mentioned, a large instance can take up to 800,000 records per second. And for a lot of use cases out there, that is more than enough. But there are other use cases, like I mentioned, like massive video streaming service, online gaming, and some aerospace use cases that 800 records per second is nothing. They are talking about millions and millions. So if that is your use case, probably it will be better for you to go the live analytics path. Why? Because even if you fine-tune the engine to the maximum, you are probably going to have little headroom for spikes and other things. So at that scale, I would say, okay, live analytics is probably a better option for you, right? And the same apply on the query path, right? Again, InfluxDB super fast, but it's an instance, right? So you are limited by the processing capacity of that instance. So a very well fine-tuned use case, you can get maybe 70, 80 queries per second, which again, a lot of use cases, more than enough. But if you want to go 300, 400, 500, I would say that probably you should look more at live analytics. I have to say that we are going to launch some extra new features later in the year that will allow Influx to go beyond that 70, 80. So just stay tuned for some very nice surprises. And the last thing is that you have to take into account is cardinality, right? InfluxDB is super fast because of the type of indexing that it used, but that also make it a little bit more, let's say, sensitive for very high cardinality, right? So I would not recommend, if your use case have a cardinality, which is the number of different time series that are being managed all the time, is over 10 million, I wouldn't recommend to go with Amazon Timestream for InfluxDB. If you are in that realm, you would probably be better with live analytics or exploring enterprise options with our partners from Influx Data, right? And what you see in the screen is something we use internally when talking to customers, and these are real use cases, right? Where to choose, right? Where your decision might go depending on these things, right? And as you see here, we are using latency and scale. Like, for example, very low latency and let's say small scale. What kind of use cases are these? For example, we have customers that are doing racetrack telemetry, right? So for example, they have a on-prem InfluxDB database on the racetrack. So they are measuring your car performance, different cars' performance in real time and making decision. And this on-prem instance is automatically doing replication to a cloud instance, because once you move from whatever, one of the US races to an European race, you will pack your stuff and go, right? But you don't want to lose that information. So usually they use these kind of hybrid deployments in which they have something on track and they have something on the cloud for other use cases. If you are doing alarm notifications for your, let's say, cloud infrastructure, most companies will have a cardinality that is below what we discussed, right? Probably 10 million is more than enough. You can have, I don't know, even 10,000 servers that you are tracking. And if you need real-time alarms and notifications, probably InfluxDB will be very good for you. Why real-time is important? Because you need to start the chain that will eventually do some change on the infrastructure as fast as you can. So we talk with a lot of these customers and they tell us, yeah, I need it to be lower than 50 milliseconds because A, B, C, or D, right? So you know your use cases, you know your needs. And so we use this kind of analysis to figure out, okay, where do you want to be in terms of the engines you can choose. And you see, like, for example, if you are in the other end of the spectrum, if you are doing root cause analysis, ML training, for do that, you need a massive amount of data, right? You need years and years of data and with the maximum level of detail. So that is where live analytics is also better because of the way it's architected. Live analytics have a hot tier, which is for the kind of real-time or near real-time kind of analysis, but it also offers a cold tier that is a lower cost storage optimized for analytics, right? So if that's your thing, if you want to do root cause analysis of an event that happened 3 months ago, and you need all the raw data that was generated, probably you will be better with live analytics.
Okay, got it. So usually when we work with our customers, like as an advanced consulting partner with the data analytics specialty, we end up in a lot of places to solve data problems. And one of the consistent pattern I have seen is like over the period of time, customers have used Microsoft SQL or Oracle or any other relational database systems to essentially manage their data-driven applications. And as a part of assessment, we try to identify from their database schemas what are the likely data sets that are likely the time stream type of data sets. And once we do that automated assessment, we recommend them that look, for these use cases, you might want to consider using Timestream DB and so on. So usually customers who are pretty much who have the build with kind of an approach, they appreciate this idea, and then if the use case is right, we help facilitate that migration to Timestream DB. Usually that's how we tend to conduct an exercise when the customer is not sure about, do I really have the Timestream data? Now, I would like, in your opinion, on how do you handle this when you speak with different customers? How do you help them see if they really have a Timestream DB use case?
So the first part of every meeting with customers is trying to understand, okay, what's the problem they want to solve, regardless of where or what tool they are using right now. Because if you start with the tool, you tend to be judgmental, and we will always try not to do that. So the first thing we try to do is understand, okay, what's your use case, right? And if you start by saying, okay, imagine we are running a very large a network of IoT devices, and it could be smart home devices, it could be like basically lighting infrastructure from the electrical grid, it could be whatever, right? If they start by saying, yeah, we are tracking all the energy meters in the city, and then they generate timestamp data every 5 seconds, that is a very good way to start for us, because that's clearly a time series database, right? So the next thing we do is, okay, how much volume we're talking about, right? And depending on the volume, that start kind of taking into certain directions, and then is, okay, what's the main use case? And if we see that a lot of the things they tell us is, oh, we want to track trends, we want to detect anomalies. All these, whenever you say, I want to detect an anomaly, I want to detect a trend, I want to do a forecast, if you really think about it, all of these are time bound, right? How do you know there is a trend? Because you are measuring something over time, and you can see, oh, the trend is going upwards, or the trend is going downwards, right? How do you detect an anomaly, right? You pretty much compare, okay, this is a performance of this device, this machine, or whatever it may be in the last 7 days, and this is the performance now. It is widely different, or maybe you can go even deeper, if seasonality, right? This is a very weird load for a Wednesday or for a Thursday, right? So all of these types of analysis that are heavily anchored on time will probably benefit from a time series database. And you don't need to go with the largest 16x large Influx DB or have petabytes of data to get the benefits. We have a lot of customers in the smaller possible deployments, and with the smallest amount of data you can imagine, that will not change that, because that is one part of the problem that is being solved in a very efficient way for them. So at the end of the day, once you start thinking about what a time series database can give you, and we talk about it here, if you have any doubts, like, oh, maybe I really need this, and it doesn't matter if you're using an RDBMS, if you're using a NoSQL database or whatever it may be, feel free to reach out to us, and we can sit with you and analyze your pain and your workload and try to figure out what will be the best solution.
Okay, so the next question is from the perspective of the pricing. Like, how does pricing for Timestream DB work, and what are the different pricing models that AWS supports?
So in the case of Timestream for Influx DB, our pricing is very similar. If you have used any of the other AWS open source databases from RDS, the pricing is pretty much using the same the same dimension. So you pay for compute, right? What is compute is you choose an instance size and you pay per hour the use of that instance. So if you use, for example, db.influx.large, which is our instance, 2 CPUs, 16 gigabytes of RAM, and that has a cost per hour. So imagine if you use only 1 day, you pay for 1 day. If you use for a full month, it's pretty much 24 hours times 30.4. And that will be your monthly bill. Storage is charged by 2 dimensions in our case, right? We have 3 storage tier. Tier 1 is pretty much comes with 125 Mbps of throughput and 3000 IOPS, right? Then we have tier 2, which is 800 Mbps and 12,000 IOPS. And then our tier 3 is 16,000 IOPS and 1 Gbps of throughput, right? And these will accommodate better or worse for certain workloads. So when you choose your tier, all you have to choose is, okay, how much storage I want to allocate, and that will be charged to you on gigabytes month, right? So if you choose 100 gigabytes or 1 terabyte, you just multiply the cost per gigabyte for 1,000 in the case of a terabyte, and that's it. That's your monthly bill. In both cases, these are charged in a prorated mode. So if you started, let's say today on the 29th, and your bill start processing in 1 day, you will only pay for 1 day because this is prorated. And what is being calculated is also hourly prorated. So you can, if you want to do a really small POC that it will only take a week, you will only be charged for the duration of that POC. Once you, let's say you delete your instance, that's it. In the case of live analytics, is different. This is a serverless, fully serverless service. So you are going to be paying there based on 4 dimensions. You are going to be paid on data ingested. Like data ingested is charged per gigabyte. So for every gigabyte of data you get into the system, you are going to pay a certain amount of money. Then we have 2 storage tiers. We have the memory tier that is, or our hot tier, whatever you want to call it, which is optimized for point-in-time queries. And this is charged per gigabyte hour. Usually in the live analytics world, we recommend our customers that they will use memory store for the edge of the data, is called, right? Most of your dashboards, most of your alarms are going to be looking, let's say 6-7 hours of data. So you optimize your configuration to the amount of data you need to be very fast, very responsive, and almost near real time or point in time queries, in which, what's point in time? You are bringing the temperature or the quality of service of one particular entity, right? It's not like fleet-wise analysis. And then we have magnetic tier that a lot of people, when they hear magnetic, they feel it's slow. It's not slow at all. It's just optimized for large-scale analytics, right? So even in some types of queries, our magnetic tier can be better than our memory tier because they were built with different goals in mind. So memory tier, gigabyte hour, magnetic tier is built for scale, gigabyte months. And the last component is queries. So the query is charged when what we call Timestream compute units, right? And this is kind of a unit of processing power, and you pay by the amount of units you use over time. So
Okay.
the thing is, you can start with 0 or a few dollars per month because your workload is very small. But you can also get to high levels if your workload start growing. So pretty much the cost that you are going to pay is directly related to your particular workloads, with all its spikes and all their downtimes and whatever.
Okay. How does the security and compliance work if someone wants to implement Timestream?
So as you know, we take security as probably the most important thing here in AWS. So both of our engines encrypt data in transit and data at rest. In the case of Timestream for Live Analytics, we are integrated with AWS backup, so you can create on-demand backups, you can do incremental backups. We are also FedRAMP high compliance, HIPAA compliance, PCI compliance. In the case of Timestream for Influx DB, we also encrypt data at rest and data in transit. We do offer service managed backups right now in case something happened to your instance. we can recover that instance. And we are working to start getting FedRAMP certification probably in the next year, I would say.
Okay. Okay, all right. A great conversation. Thank you so much, Victor, for taking all these questions.